Hello and good morning, good afternoon. Welcome to our webinar, which is entitled Prize Opportunities Using D4i and Zhaga Book 20. My name is Tim. I'm the Marketing Communications Manager for the DALI Alliance, and I'm going to be at least involved doing the Q&A later on. The webinar today is presented by PNNL and the DALI Alliance and the Zhaga Consortium. We have 3 presentations which will last for a total of between 40 and 45 minutes, and then we're going to follow that with a Q&A session. So during the presentations at any time, please type your questions into the Q&A box. The presentation materials will be available after the event, along with the webinar recording, and the URL on the DALI Alliance website is shown there, and I'm sure that Zhaga will also post the information as well. So the 3 presenters that we have today are Gabe Arnold from PNNL, Scott Wade from the DALI Alliance, and Adrian Green from ANSI, also representing the Zhaga Consortium. So without any further delay, I'm going to hand over to Gabe. So just bear with us whilst we do the transfer process. Okay, Gabe, if you want to share your screen, you should be all set.
Okay, thank you, Tim, and welcome everybody. As Tim said, I'm with Pacific Northwest National Laboratory. We are the technical lead for the L Prize. If you're not already familiar, the L Prize is a U.S. government-sponsored competition by the U.S. Department of Energy to encourage groundbreaking innovation in highly energy efficient, connected, and sustainable commercial lighting systems. Cash awards are offered with $12.2 million in total prize money. I want to thank the Zhaga Consortium and DALI Alliance for hosting this webinar and providing us the opportunity to share this information about the L Prize, especially towards the L Prize standards-based interoperability objectives. As you'll hear, standards-based digital interoperability between luminaires and connected systems is an important objective of this L Prize competition to support advanced lighting system capabilities and the widespread adoptability of winning solutions. The D4i standard that's managed by the DALI Alliance and its North American counterpart, NEMA ANSI C137.4, provide for this digital interoperability and have a central role in the competition. I and the other speakers will share a lot more about that shortly. I'd like to tell you a little bit more about the competition broadly. The L Prize targets commercial and institutional sector lighting, such as offices, schools, healthcare, and any winning entry must be a luminaire or lighting control system designed for those types of applications. These are applications where there remains significant energy savings potential. There is still a lot of installed fluorescent out there, but it's also where the advanced capabilities of connected systems can provide tremendous value for both building optimization, energy optimization, for business systems, as well as for building occupants. The competition is organized into 3 different phases: a concept phase, a prototype phase, and a manufacturing and installation phase. The concept phase was just completed this past February, where we had 4 winners of the 20,000 each awards. The prototype phase is open right now. As you move through the competition, move through the phases, the stakes go up, the prize money increases, and the number of winners reduces. We have a $2 million prize pool for the current prototype phase that's open, and a $10 million prize for the upcoming manufacturing and installation phase that will kick off in late 2023. If we zoom in on these phases in more detail, the first phase, the concept phase, required documented concept designs of lighting systems to be submitted. These were really just designs on paper. The current prototype phase takes things a step further and actually requires physical working prototypes to be submitted that will be physically evaluated by an expert panel. There are up to 6 winners of this current prototype phase, and then the final phase, the manufacturing and installation, requires winning solutions to be or become commercially available. And there's up to 4 winners for that final phase that will split a 10 million prize pool. One aspect that we want to be clear about is that each phase is like a separate competition. You don't need to participate or win a prior phase to participate in the next one. And in fact, the Department of Energy invites, welcomes, and encourages new participants in each phase. There are many innovation opportunities and pathways you can take to win this competition. It is a points-based competition. The competitors with the highest points are recommended by the expert panel as winners to the Department of Energy. You can earn points in 6 different categories: efficacy, quality of light, connectivity, product life cycle, which includes sustainability, general technical innovation. There are some specifics there we'll talk about in a moment, and then diversity, equity, and inclusion in the team that's developing the innovation or in how it's deployed into the market. If you have innovations in one or more of these areas and can meet the minimum requirements, we strongly encourage you to enter this competition. There are some exciting new changes that we rolled out with this prototype phase. We had published draft rules prior, and now that we've rolled it out, there's a few new things. So first of all, we now have 2 tracks. There's one for luminaires and one for connected systems. This used to be combined. A connected system is basically a lighting control system. So you can win this with either a luminaire submission or a lighting control system submission. You can submit an entry to one or the other, or entries to both, and it's possible to win both for a single organization or team. Secondly, we've increased the number of potential winners of this phase from 4 to 6 from the draft rules that were published prior. And third, we've expanded the innovation opportunities that can earn points and help win the competition. All of these changes are really designed to offer more pathways and opportunities to participate, to be recognized for innovation, and win the L Prize awards. Here is what the 2 tracks look like: the luminaire track on the top and the connected systems track on the bottom. The luminaire track has requirements and innovation opportunities in the areas I mentioned earlier: efficacy, quality of light, connectivity, product life cycle, technical innovation, and diversity, equity, and inclusion. The categories for the connected systems track are fewer. There's 4: connectivity, product life cycle again, technical innovation, and diversity, equity, and inclusion. Under each of those categories, you'll find either mandatory minimum requirements that any winning solution must meet, or optional points you can earn, or in some cases, a combination of the 2. There's a lot here. As I mentioned, there's lots of different pathways you can take, lots of areas where you can earn points that are represented by the open checkboxes on this slide. On the luminaire track, if you look at that blue bar, the technical innovation, for example, you can even earn points for things like innovation in form factor and aesthetics, which can support the adoptability of the solution. There are lots of points available for sustainable circular economy features, an issue of growing importance in the lighting industry. On the connected systems track, again, if you look at the blue section there, for technical innovation, we have points for things like ease of installation and use, a critical issue for these systems, for innovations in compatibility and interoperability, for innovations that improve the value proposition or reduce the cost. Again, there's just so many different pathways you can take here to earn points and be recognized for innovation, and we encourage you, if you've got innovation in one or more of these areas, to enter the competition. The part that we're talking about today is the connectivity portions. Specifically, under the luminaire track, highlighted in blue, you can see it requires a standards-based digital driver and a standards-based sensor port and connector. These are check marks, so they are mandatory. This is not optional. And then on the connected systems track, you've got kind of the counterpart. requires a standards-based luminaire or a system controller and a standards-based luminaire level lighting control, which is basically a sensor. If you go to the official rules of the L Prize and download those, you'll find in Appendix A and B all the details of what this is specifically asking for. What this is referring to when it says standards-based is the subject of today's webinar. These are the D4i and North American counterpart, NEMA ANSI C137.4 standards for digital interoperability, and Zhaga Book 20 and NEMA LS 20000-21 that define standardized sensor port shapes and sizes. These standards provide for digital interoperability between luminaires, installed sensors, and connected systems. They help ensure that the digital interoperability of any winning luminaire with a wide variety of available connected control systems and sensors, and vice versa. The Department of Energy's goal here is to support the widespread adoption of winning luminaires and winning connected systems, as well as the advanced features that these digitally interoperable systems can deliver, far beyond what can be achieved by today's analog 0 to 10 volt system, which dominates the market in the United States. We've got to get past 0 to 10 volt control. It's easy, but it is very limiting in terms of its capabilities. Supporting a standards-based approach helps to support the wider adoptability of winning solutions. I'm going to break this down a little bit further, but I know our other speakers will address it in more detail as well. So first, looking at the luminaire track, what is asked for here, as you'll find in Appendix A of those official rules, is that a luminaire must have a D4i or NEMA ANSI C137.4 compliant driver. Those are available off the shelf. And a Zhaga Book 20 or certain shapes of NEMA LS 20000-2021 compliant sensor port or receptacle, and a standardized connector for the sensor to connect to the driver. That is a mouthful there. First, this approach provides a non-proprietary standard connection for a sensor to be installed in a luminaire at any time. Secondly, it provides for non-proprietary standardized data from the luminaire stored in the driver, which includes luminaire energy data, luminaire asset data, and luminaire operation and maintenance data that can be shared with a connected system or a third-party system in a standardized format, enabling advanced capabilities and use cases. And then on the connected systems track, it is basically the counterpart. You must have a standards-based luminaire or systems controller and a standards-based luminaire level lighting control or sensor. If you, again, go to the appendix of the L Prize official rules, Appendix B for the connected systems track, we find that this means the connected system must be able to communicate with and control a luminaire or sensor that complies with D4i of the NEMA ANSI C137.4 standards. We want to be clear, D4i, as we'll hear a little bit later, if you're not already familiar, is a DALI standard. But we want to be clear, this doesn't mean that the connected system must be a DALI lighting control system. The connected system could use Bluetooth mesh, it could use Zigbee, it could use a proprietary protocol as its primary communication method. It just needs to have an interface or a controller to a D4i driver, luminaire, or sensor. There are already gateway specifications available for some of these interfaces. There's one available already for a Bluetooth mesh to D4i gateway. There's one available for a Zigbee to D4i gateway. So these are out there. But this does give you the freedom with the control system to use any protocol you want. What we're talking about here is the use of DALI just inside the luminaire. And then secondly, the connected system must provide a sensor that can be installed into a standard shape and size sensor port in the luminaire, specified by Zhaga Book 20 of certain shapes of the NEMA LS 20000-2021 standard. Similar to the luminaire track, this standards-based approach will mean that any winning connected system will be digitally interoperable with a wide variety of luminaires on the market and help support that widespread adoption of the solution. Another outcome of this that's important to the Department of Energy is that any winning L Prize luminaire would be digitally interoperable with any winning L Prize connected system. And that's going to provide a lot of benefits as DOE looks to support the deployment of these winning solutions in the market. A couple more things I'd like to mention before I turn it over. With the opening of this current prototype phase, we also published draft rules of the manufacturing and installation phase. And we're looking for input on these. There's a comment form that you can complete to provide input. Is what we put forward in this next phase achievable? Are the timelines feasible? Do you have better ideas for us? Any feedback you have, we welcome it. So I wanted to make sure that people are aware of that opportunity. And then we've had a lot of questions about teaming for this L Prize, and we have a couple of mechanisms to support that. For the current prototype phase, the HeroX platform that we use to administer the L Prize has several functions to support potential teaming of partners. On that platform, you can express your interest in forming a team, or you can see who else has expressed interest in what particular aspects or capabilities they bring. There are already some potential teaming partners listed in HeroX, so you can check that out. And then we have a separate teaming mechanism we've currently opened for the future manufacturing and installation phase through a request for information or RFI. If you are a possible manufacturing or deployment partner, if you make materials or components that might be used in submissions, for example, if you make D4i or ANSI C137.4 compliant drivers or sensors, we encourage you to respond to this RFI and get listed so that competitors can see that you're interested in providing components that would be eligible for this prize. More information on both these teaming opportunities is shown on the slide, and these slides will be made available. There is all kinds of helpful information on the L Prize websites, the American Made Challenge website and the HeroX platform. We've got videos, webinar recordings, forums, examples, and more. So check that out. And that concludes my portion. As Tim mentioned, please write your questions into the pane. You can also at any time email us lprize@nrel.gov. And on that HeroX platform, we have a forum where we post answers to questions that have been received. So there's a lot of questions already populated on that forum. So thanks so much, Tim. I'll hand it back to you.
Thanks, Gabe. I'm handing over to Scott. You should be able to share your presentation now, Scott.
Yes, should be sharing now. Thank you very much. Thanks, Gabe. Thanks, Tim. Good morning, good afternoon. I'm Scott Wade. I'm the Technical and Certification Manager from the DALI Alliance. And I'm going to show how D4i and DALI 2 can help during the prototype phase of the L Prize. So this is the agenda. So I'll first introduce DALI, DALI 2, D4i, and the DALI Alliance, but quite quickly, and explain what D4i is. Then we'll look at the two tracks, the luminaire track and the connected system track, what's needed for those, how D4i can help there. And then we'll look at testing and certification. So first, the DALI basics. So DALI is Digital Addressable Lighting Interface. It's an industry standard protocol. It gives bidirectional digital communications between lighting control devices. So you can talk to devices, you can query, ask questions, get answers back, configure and control. It's dedicated to lighting with a rich feature set, and it comes from this global standard IEC 62386. DALI 2 is the certification program based on the latest version of the DALI protocol. It's driven by the DALI Alliance, also known as DIIA, and DALI 2 ensures interoperability through the testing and certification with the trademark use. And these are the trademarks: DALI, DALI 2, D4i, DALI Plus. These are all owned by the DALI Alliance, controlled for use by our members. So the DALI Alliance is an open global consortium of lighting companies that aims to grow the market for lighting control solutions based on DALI, also known as Digital Illumination Interface Alliance, but that's a bit of a mouthful, so it's easier to say DALI Alliance. We have more than 320 members now worldwide, and many of them are industry leaders in lighting and control. To see the full list, have a look at the website. Membership allows certification or registration of products. So certification, that's DALI 2, and we have over 2,600 certified products today. And registration, that's DALI version 1, so over 1,600 of those. Membership allows use of the trademarks with the DALI, DALI 2, D4i, and soon the DALI Plus trademark. So what is D4i? It's an extension to DALI 2. So D4i control gear, the drivers, they include a mandatory set of functionality. So it's what DALI 2 brings plus some mandatory functionality must be in there. D4i control devices, similar to DALI 2 control devices, plus a bit of mandatory functionality to aid plug and play. Luminaires, so D4i luminaires that is, they require 1 to 4 D4i drivers. And D4i is targeted especially for intra-luminaire use, where DALI is inside the luminaire. All D4i LED drivers provide luminaire data, power and energy data, and the diagnostics or maintenance data. That's all in the D4i drivers. This enables DALI inside intelligent IoT-ready luminaires. Some D4i drivers also provide other functionality, such as color control or emergency lighting. And D4i simplifies the addition of sensors and communications devices to luminaires. It enables plug-and-play interoperability when combined with a connector system. For example, Zhaga Book 18 or 20, or NEMA ANSI C137.4-2021. And Adrian will be explaining more of that later. So what's needed for the luminaire track of the L prize? So the driver requirements for luminaires. So they must be LED drivers meeting D4i or ANSI 137.4. The dimming range has to be down to 5% or lower is acceptable, obviously. Now, if all drivers are also capable of switching off, that's a mandatory requirement of D4i. All DALI or D4i drivers can also switch off. Sensor port, you'll find out more about that later from the Zhaga part of the webinar from Adrian. Optional white tuning capability. So in the prototype phase, the luminaire output is to be fixed at 4,000 Kelvin. So that's the color temperature, the CCT value. But the white tuning capability could be an advantage for the next phase of the competition. Now, just to illustrate what a D4i luminaire looks like, it's pretty straightforward. You've got a D4i LED driver inside, so at least one of those. Now, they have an integrated bus power supply and the DALI data parts of the standard. That's all part of that LED driver. And there you can see the LEDs connected to it, so the lamp module. Now these parts of the standard are they're in all D4i drivers, so parts 250 up to 253. So that's the power supply and the data parts. They're in all D4i drivers. Now the bus connection is a 2-wire DALI bus coming out of the driver, and that has power, the DALI bus power and data on the same 2 wires. And that's inside the luminaire. And you can see here it's going to a sensor port, and that could be a sensor or a communications device, or both. Could be a device combining both. And that implements this part of the standard, DALI part 351. That's the luminaire mounted control devices. Now, what about the connected systems track of the L prize of the prototype phase? So D4i products can help meet many of the requirements here. So the controller itself must be able to control the D4i or ANSI 137.4 drivers across multiple luminaires. I believe the testing is up to 4 luminaires. It also needs to interface to another network. It could be Ethernet, Wi-Fi, Zigbee, 6LoWPAN, Thread, Bluetooth Mesh, or something else. So that's the interface. And connectivity to luminaires. Communication could be through the DALI bus, the 2-wire bus that connects the drivers and the sensors, or through one of these other interfaces. So a wireless interface, for example. Data access is provided, so the luminaire data, the power and energy, and the diagnostics and maintenance data is all available from the drivers, and that must be leveraged by the connected system. An API, application programming interface, provides access to the data, so all that information from the drivers and even the sensor itself provides a little bit of data. So that is to be available through an API, and that can give also occupancy information, fault information such as lamp failure or control gear failure, the power and energy information, temperatures, and so on. And the bold format here shows data provided by the D4i drivers and sensors. The zone information is usually programmed into the drivers, so the information on the zones or the groups that drivers are to be operating in is usually programmed over the bus. Addressability, so devices need to be individually addressable and reconfigurable. So that's provided by all D4i drivers. Energy reporting, so that's available from the drivers and has to be extracted by the control system. So that allows fully automated measurement, reporting, and logging. So other requirements that D4i products can help to provide: lighting control strategies, that's mentioned in the rules. All are possible, all the strategies mentioned are possible with the D4i or DALI 2 system. System resilience, so the configuration of the drivers includes automatic power on level settings, that helps with system resilience. And all the configuration is stored in non-volatile memory in the D4i drivers. The control devices, including sensors, can automatically issue a power notification message after detecting a power cycle. So that helps the system controller decide if any action needs to be taken. It helps it realize there has been a power cycle for some devices and decide on any action. Fault detection and diagnostics, that's built into the drivers. So reporting of lamp problems, that's in all DALI 2 drivers and D4i, but D4i gives additional diagnostics and maintenance data. So including temperatures for the driver itself, possibly for the lamp module, lifetime or operating hours, that information is all in there. Standards-based luminaire level lighting control, so D4i or ANSI 137.4 compliant control devices can include occupancy and light sensing, so you can choose control devices that include those features. And examples can be found in the product database. That's from the DALI Alliance website. There is a link there, so when you get this presentation, you can follow the link to the DALI Alliance product database and search for products. You can filter, for example, if you're looking for occupancy sensors, you can filter just to show all devices that include occupancy sensing, just as an example. Grid services capable, so a simple method to implement this would be to set the maximum level depending on the demand response from the utility. So if the utility says that please reduce the demand, then the D4i system could have a command over the DALI bus to limit the maximum level that the lights are allowed to go to. So that's a simple method of achieving demand response. Data specifications, just to show what's in these parts. So these are the parts that are in all D4i drivers. So the luminaire data in part 251, and all of this information is in there, programmed by the luminaire manufacturer. Part 252 is the energy and power reporting part. So it reports not only the driver power and energy that it's using, it can also report power and energy delivered to the lamp, so it can report that separately. And some drivers can support more than one lamp. The diagnostics and maintenance data is in part 253, so that's data for the control gear and the lamps, including failure conditions, runtime data, and information to help with predictive maintenance. Those specifications are available from DIIA, but also included in ANSI 137.4, so they're referenced from there as well. So just to show you what ANSI C137.4, the latest version, this is what it looks like. It includes all of these parts of all these DIIA specifications. These first 5 are for the LED drivers, and that last one is for control devices. The original publication of C137.4 only included those 3 parts, but the 2021 version includes everything there. That part 150 is optional. That's an auxiliary, it's a 24-volt power supply. It's really used mainly for outdoor luminaires, so not so much for indoor. Just an example, using the data. So in the factory, the luminaire data is programmed into the drivers. In the field, the luminaires can automatically transfer that data to a remote network, reduces human error, saves installation time and cost, and allows a full map of asset information. You've got performance monitoring using the energy data, for example, for billing, and also data for predictive maintenance. So it's all possible. Testing and certification, just to explain how this is done for the products. So testing can be done by either a DALI Alliance member, so they can test their own products, or they can use an accredited test house. And test houses are listed on the DALI Alliance website, currently 10 test houses, all listed there. Certification is where the test results are submitted and then verified by us at the DALI Alliance before we grant D4i or DALI 2 certification. So that's an independent check of the test results and the product information. Once certification is granted, the products are publicly listed on the website. So there's the link to follow to the product database. So you can search for all the certified products. And just to look at, to have an overall view of the D4i and Zhaga-D4i certification for the different types of product involved here. So we've got LED drivers. So that involves the DALI Alliance members testing and certifying the products. And that allows D4i certification. The control devices, so they also are tested and certified by the DALI Alliance members and listed on the website as well. Now they can then go on to be tested and certified by Zhaga test houses to get combined Zhaga D4i certification. So of course they'll need to meet the extra requirements from Zhaga, for example, the electromechanical interface. Luminaires, so they first must use D4i components inside, so that's the first step, and then the checks on that are done by the Zhaga test houses to get Zhaga certification, so the Zhaga D4i is achieved there. Then the connectors themselves, you'll hear more about from Adrian in a few minutes, and that's all handled by the Zhaga certification, Zhaga test houses, to achieve Zhaga logo. Okay, that's everything from me for now, so please remember to add your questions to the Q&A box. But for now, I'll hand over to Adrian.
Thank you, Scott. Really great presentation, some powerful capabilities in the D4i. It's good stuff. All right, I will share my screen. Everybody see that okay?
Yeah, looks fine.
Great. All right. So I'm Adrian Green. I'm the working group chair for Zhaga Book 20. And I would like to introduce the smart interface between indoor luminaires and sensing communication modules. Zhaga Book 20 offers many advantages for smart LED luminaires with IoT connectivity. The Zhaga promise of interoperability is a key principle to bring the features that are shown on this slide here. Connected, intelligent, versatile, future-proof, standardized, and certified solutions for LED luminaires. We've recognized the need for smart, future-proof LED luminaires, which are easily upgradable to take advantage of the rapid developments in digital networking technology. So the solution is the Book 20 Zhaga-D4i interface standard. A simple way to add sensors and/or communication modules to luminaires, Zhaga and the DALI Alliance collaborated to develop and maintain a standardized interface between luminaires and sensor and/or communication modules. A combination of complementary specifications for mechanical fit, digital communication, and power supply for the modules. And the Zhaga-D4i certification program helps ensure full interoperability. This slide shows an illustration of the Zhaga Book 20 system. We have an indoor luminaire, which can include one or more LED drivers. There's a communication and power supply protocol, and a mounting slot, which is defined within Book 20, and I'll discuss in more detail. And then there's a standardized connector solution, so a plug-in receptacle connector, which enables optional sensor and/or communication modules to be connected to that system. Features of the Zhaga-D4i interface standard. So it's easy to add or upgrade sensors or communication modules. It enables future-proof luminaires that can keep pace with rapid developments in digital lighting and sensing technologies as they come along. Interluminaire DALI 2 bus. So we have the bidirectional communication between sensors and/or communication modules and the LED drivers. It's enabled by using the well-established and standardized DALI 2 protocol that Scott spoke about. D4i drivers are smart, as Scott had described in detail. The operational and diagnostic data can be reported to an external network, and inventory-related information about luminaires can be provided. And with a suitable wireless communication module, luminaire is able to interact with an external lighting control network to become part of the Internet of Things. So we have complementary specifications between Zhaga and the DALI Alliance. Scott had touched on this earlier about the various parts of the D4i, including the integrated bus power supply, the luminaire data for asset management, energy reporting for drivers, diagnostic and maintenance data for drivers, and the ability to enable luminaire-mounted control devices. The Zhaga Book 20 adds to this is the specifications for the mechanical interface between the module and luminaire, which we'll speak about in the next few slides. There's a specified electrical connector, which brings them together. And there's a specification for the luminaire's electrical interface. Book 20 provides several different mounting options. As you can see here on this slide, there are 3 primary different types. You can mount a module from inside of the luminaire into the specified opening, or sensor modules could be installed from outside of the luminaire in either of the fashions shown here. And then we've also got an option where the module can be attached to a fixture or bracket, which could then be mounted to the outside opening of the luminaire as shown. There are 5 standardized form factors which are defined in Book 20. 2 of them are rectangular and 3 of them are cylindrical. So in the rectangular options, we have a 44 by 17 millimeter version, as well as a 60 by 22 millimeter version for larger, more complex modules. The cylindrical versions are all utilizing the same 22 millimeter diameter hole, but each of these defines slightly different demarcation models for space allocation inside the luminaire for the sensor to fit into, as well as keep-out zones on the external area of the luminaire for lens protrusions. Zhaga and the NEMA organization have worked in partnership to align our requirements wherever possible between Book 20 and the LS 20000 standard. So this chart below here, this is a cross-reference of the compatible NEMA sizes to match the Zhaga Book 20. So you can see we have our 2 rectangular form factors and the naming convention used in Book 20. And then there are cylindrical options and the names associated with those. And then we can see the corresponding versions that are defined in the NEMA LS 20000 that match with those. So the modules that comply with Zhaga Book 20 will also comply with the corresponding LS 20000 sizes that are shown on this slide. So that helps ensure that we have compatibility between our standards. So features of the electrical connector. We have a 2-position plug-in receptacle interface that's defined. It makes it easy to use the separable connection between the module and the luminaire to provide the DALI connectivity. Poka-yoke features prevent incorrect mating. They help enable connectivity with the polarity ensured. And the connector provides fingerproof protection. So the housing provides touch-proof protection for the separable contacts there. We have plug-and-play functionality, which can allow the modules to be installed by a generalist. There's no need for an electrician to be involved in upgrading a luminaire by adding a new module. And we have an integrated latch feature to provide a minimum of 5 newtons retention when the connectors are mated, and that will just help ensure that the connectors remain intact over their lifetime. The Zhaga Consortium and DALI Alliance have worked together to create a joint certification program for interoperable luminaires and sensing communication modules. So it's based on the complementary specifications from Zhaga and the DALI Alliance. In this case, it's the Zhaga Book 20 plus the D4i specifications. So the product certification allows for the use of the Zhaga as well as the D4i logos on indoor luminaires, sensing and communication modules. The logos help ensure that we have product interoperability from multiple different vendors. And LED drivers are eligible for the D4i certification from the DALI Alliance. So the benefits of this certification program. So certification gives confidence for interoperability, which is key to making the system work. Certifications are carried out by independent authorities. The products are traceable in public databases, and the certification logos are trademarked to prevent misuse. Certification gives business advantages. So certified luminaires and components are available from multiple suppliers. The logos provide an established brand for product marketing. And certification ensures that luminaires are future-proof and will be able to host next-generation Zhaga-D4i modules that will come in the future. So the scope of the certification. So essentially, the connectors themselves, which are certified to Zhaga Book 20, are able to hold the Zhaga logo. Certified drivers can have the D4i logo attached, and the modules and luminaires can include the Zhaga D4i logos. This slide shows an overview of the certifications for Book 20. So just visually portraying. So we have the Zhaga D4i certification for luminaire, as well as the sensing and or communication modules. LED drivers have the D4i logo, and the connectors can hold the Zhaga certification. So just a summary of the certification. Zhaga and the DALI Alliance have developed this joint program for indoor luminaires, which is based on the standardized interface between drivers, luminaires, and sensing and communication modules. Zhaga D4i certified luminaires will be the backbone of intelligent building management systems. It creates a simple way of adding control sensing modules into building system architecture. A large ecosystem of modules will become available for Zhaga certified luminaires, which will allow a selection of luminaires today for the technology advances that sensing and control modules will bring tomorrow. Adding the requirement of Zhaga D4i certification simplifies the tender processes. The certification provides assurance of interoperability and gives confidence that different parts of the system will operate together. All Zhaga D4i certified products will be traced through an easily accessible database on the Zhaga website. So the next couple of slides describe the certification process for the various different elements of the Book 20. So if we start with the Zhaga D4i modules, the manufacturer would be an associate or regular member of the Zhaga Consortium as well as the DALI Alliance. They would begin by designing the product to comply with those standards. The product will be self-tested or tested by a DALI test house. The results will be submitted to the DALI Alliance for verification and certification. The product documentation would be submitted to the Zhaga Test Center, and it would be tested for compliance against the Zhaga specifications in Book 20. The product would then be awarded the Zhaga-D4i certification and allow the use of the Zhaga and D4i logos. For luminaires, the manufacturer would need to be an associate or a regular member of Zhaga. They would design the product in compliance with Book 20. They would compile the required documentation and submit it to the Zhaga Test Center. It would be tested for compliance against Zhaga specifications, and then the product would be awarded Zhaga D4i certification and allow the use of the Zhaga and D4i logos. And for connector components, the manufacturer would need to be an associate or regular member. They would design the product in compliance with Book 20. They would compile the required documentation and sample and submit it to the Zhaga Test Center, where it would then be tested for compliance against the Zhaga specifications, and the product would be awarded Zhaga certification and allow the use of the Zhaga logos. So there is a short summary of Book 20, which is available on the Zhaga website, also on YouTube. You can follow the 2 links there below. Kind of gives a quick summary. It's about 2 minutes of everything that I've just covered in kind of a snapshot. So it's a helpful link that you may want to look at later or share with your colleagues. And thank you so much for your time. I appreciate your attention.
Great, thanks Adrian, and thanks also Scott and Gabe for your presentations. We're going to do a Q&A session now, so please, if you have any questions, type them into the Q&A box, and we will answer as many as we can. So the first question, it looks like entries for the L Prize have to be both DALI certified and Zhaga certified. And the second part of that question is, what is the estimated cost to conduct these testing and certification procedures? I think maybe for the first part, Gabe could probably answer that one.
Yes, I think I'd like to take that as well. There's another question that's sort of related. Is it required to join the DALI organization, which, as Adrian just presented, is required for certification? Thank you for this question. I can see how these questions, I can see how they're a little bit confusing. There is nothing in the L Prize rules that requires you to join either the DALI organization or the Zhaga Consortium, and that is intentional. The L Prize rules do not require, for the prototype phase, products to be certified to DALI or to Zhaga. Certifications are very valuable for some of the reasons articulated by the other speakers, but that is not required by the L Prize. All that's required by the L Prize is test results to demonstrate compliance with D4i and ANSI C137.4. You need to submit test results, and that is testing you could conduct on your own if you purchased the testing equipment and obtain the test sequences to do that. But that's somewhat of an expensive undertaking to do that. That's more suited for companies that would be pursuing these test results and certifications beyond just the purpose of the L Prize, like for a driver manufacturer or something like that. The other way to get those test results would be through a DALI test house. And there is a list of those test houses published on the DALI Alliance website. There is one in the United States. It's Intertech, located in Chicago. I do not know the exact cost of obtaining that testing. We have had some conversations with that test house. I don't want to give I don't think it's a fixed amount. It's probably going to vary depending on how much you're testing and maybe how much of a customer you are and so forth. But the numbers that I have been quoted are fairly, I'll say they're fairly reasonable, and leave it at that. So I think that's my portion of the answer. I don't know, Scott, if you want to add anything to that.
Yeah, I can't give costs either, but it does vary with the type of product. So if you're getting an LED driver tested, it will take quite a bit longer than it would take for a sensor, for example. An LED driver might take 2 or 3 days to complete the testing, whereas a sensor could be done within 1 day. So, of course, the costs will vary, but please contact the test houses directly for pricing. Okay.
Yeah, thanks, Scott. Adrian, anything to add on that?
No, I think it was well covered. Thank you.
Okay, great. There is actually a follow-up to that question, Gabe, that just came in. Do we need to buy the testing procedure?
If you're going to conduct your own testing, you're going to need to purchase the specialized, it's called Probit Lab 2 testing equipment. That's quite an expenditure. And then you'll need to obtain the testing procedure itself from the DALI Alliance. I do think that's something that's available to DALI members at no cost. And so that would be how you can get that. And Scott, did I have that right?
Yeah, that's exactly right. I'm not sure though if the question is about DALI testing or is it possibly the L-Prize evaluation, the testing of the products being submitted to you. I'm not sure.
Well, there would be no cost from the Department of Energy to any entry or competitor to evaluate their product. Basically, you would submit to us the physical product itself, as well as documented test results, such as the DALI and ANSI C137.4 test results, and things like LM79 test results and so forth. But there's no cost that we would charge to a competitor to provide that to us.
Okay, great. Let's.
I guess I'll just add one point to that related to getting the specifications and so on. So the Zhaga Book 20 specification has been made available for the L-Prize competition as well. And I think, Gabe, you've got a link to it in some of your documentation, I think in the rules, or links to the Zhaga website for the download of that.
Yeah, this is spelled out in pretty good detail in Appendix A and B of the rules.
Okay, good. Separate question. Is there a list of manufacturers who provide Zhaga compliant sensors with connectors?
So there will be a database on the Zhaga website for available sensors and approved products. I think that there are products which are in the process of certification right now and should be starting to show up on the database in the near future. So you can look on the Zhaga website and browse for certified products.
I think maybe I'll add something to that. We received some questions about this before, and you can find some information on the HeroX forum that I talked about, where we've answered a question related to this. You can find, as Scott kind of went through, on the DALI Alliance website, you can search for sensors that comply with D4i. But it doesn't say whether or not those sensors have the Zhaga connector. Given that this is relatively new, and as Adrian said, some of these sensors are coming to market, we will allow the Zhaga connector to be spliced onto a D4i compliant sensor for the purpose of the prototype phase with L-Prize. So it does not need to have that Zhaga connector hardwired into it. If that makes sense.
Just to update, there is connector information on the DALI Alliance website as well. So you can search for a sensor, you can say you want a D4i sensor, and you can specify its Zhaga Book 20 connector on it as well. Of course, you need to check the Zhaga website to find out if it is a Zhaga certified product already. But the search filters include that on the DALI Alliance website, include the connector type.
I think as Gabe described, I think it's a fairly simple process. If you have a D4i component, to splice on the Zhaga Book 20 connector on the end of it, and you've got a prototype.
Yeah.
Okay, great. Another question: does every luminaire, either connected or wired, need to have its own 16-volt, 250 milliamp DALI bus power supply?
Not exactly. So the DALI bus power supply is actually built into the D4i drivers. It's part of those already. Every D4i driver has this power supply, so there's no additional power supply required for the DALI bus. And the power supply inside the drivers is not as large as 250 milliamps. It's typically around 50 to 55 milliamps, so that you can have up to 4 of those in a small system, or usually within one luminaire, and you're still within the 250 milliamp limit. So there's no additional power supply needed. It's all part of those drivers already.
Okay, and a related question, I think. What if there is a daisy chain system where each luminaire is connected to the next? Since each connector only has 2 wires, won't this require duplicate or even triplicate Zhaga connectors, especially if a sensor is required as well?
Right, I'm not completely sure about the question, but every luminaire would have the Zhaga connector to allow a sensor to be attached. Doesn't mean there is a sensor attached, but it has that possibility. So they could have them, or they don't need to. Not sure if that answers the question, but you're right, they are connected. If you're connecting a system of luminaires, then yes, they connect through the 2-wire bus.
Okay, good. I'm not seeing any further questions.
I just see one just added. I'm just reading it to see if it's directly to me or if it's for here. So it's a question about someone that's developing the DALI stack, the DALI software. And sorry, it's just scrolling up. So yes, you can develop the products without joining DALI, so that is possible. The DALI 2 and D4i are based on published standards, so IEC 62386 and also the DALI Alliance standards, so they can be downloaded freely from the DALI website. So you can develop without joining. So just go to the website and look for D4i and you'll find the D4i specifications that you can download. The ones you need depends on the type of product, of course. You've got control gear or control devices, so they're different standards. So just please contact us and we can give you guidance on that. Okay?
Okay, good. All right. Thanks very much, everybody. Thanks again, Gabe and Scott and Adrian. Sorry, Adrian. Thanks very much, guys. Good job. And
Thanks,
as we said,
everybody.
we'll put the presentations onto the website as soon as we can, and also the recording. Very good. Thanks very much for attending, and goodbye.
Thanks.
Thank
Bye.
you. Bye-bye.
Thank you. Bye-bye.